Good morning, class. So this is the second time I made this video because the first one wasn't working. So let us do this again. So first step for any problem is read the problem. So try this on your own first. Read the problem, draw a diagram, try to solve for your forces and what you care about. This one is tricky, so if you get stuck, come back to the video. Alright, do it yourself. Alright, so now you're done, let's read it together. Angelica just got a new puppy and takes it out for a walk across Icy Lake. Unfortunately, the puppy is very lazy and she has to pull it in a sled across the ice, which has a coefficient of kinetic friction of 0.01. If Angelica pulls the puppy and the sled by a rope at an angle of 15 degrees, and the puppy and the sled have a combined mass of 18 kilograms, with what force must she pull it in order to maintain a constant speed? So draw your diagram first. I'm going to draw it in the corner. So here's our sled with our puppy. Angelica is pulling it at a 15-degree angle. The puppy has some gravity, which means it's on an icy lake, so it does have a normal force, and there is some friction. So we need to figure out, and I'm going to call this F tension. We need to figure out how much is she pulling it, and yes, that does mean we will have to break this up into an X and a Y direction. So you want to have both an X side and a Y side for this. So we want to talk about our X and Y components. So our X components would include things to the left and the right, so that would include force of friction, and it would include our tension, but not all of our tension, so think this is the adjacent side to the angle, so we'd use cosine of 15 times the hypotenuse, or also known as our force of tension. For the Y direction, we have some more things going, because we have the force of gravity, the normal force, and the force of tension, but now it's talking about in the Y direction, so it would be sine in this case. If you're not sure why I chose cosine and sine, please come in and see me and we can have a greater discussion on it. So this is kind of difficult, but we do know it has to be constant speed, so at the end of the day, all of these things are equal. So probably did not draw my free body diagram scale, but what you should know is that at the end of the day, all the X forces up and down will be equal, so your net at the bottom of all this for each one should be 0. That's important, because that means if we were to put this into an equation, for the force in our X direction, it would be the right minus the left, so force of tension times cosine 15 minus the force of friction, or added, because friction is the opposite direction, it would be negative. This is all equal to 0, which means we can do some cool things with it. Same thing is true for the Y. Be F of Y is equal to force, let's do up forces first. So it'd be the normal force plus, because it's in the up direction also, the force of our tension times sine of 15, and then minus our force of gravity because it's down. And again, all of this will be equal. From here, you guys start filling in some equations for these, because we can figure out, anytime you have gravity, you can figure out what the force of our gravity is, because we know, hey, this thing is 18 kilograms, and we know that the acceleration on Earth is 9.8, or about 10 meters per second squared. So you know that that's 180. We also know the formula for the force of friction, and we do have the mu. So I'm going to move this over to become a little nicer looking equation. Ft is equal to cosine 15. And we know that the force of the friction is equal to the mu times, I'll write it over here. So just so you know, the force of friction is equal to, and this is the kinetic, mu kinetic times the normal force. So you're going to get mu kinetic, which is 0.01 if we looked at our problem, times the normal force, which we don't know yet, is equal to Ft cosine 15. And we can do the same thing over here, so I'm going to plug in 180, but I'm going to move that 180 over to the other side, so we get 180 is equal to Fn plus Ft sine 15. So now we got two equations, two unknowns, because we have unknown Fn and unknown Ft. So, I know you're excited to hear this, we now get to combine these things. You get to plug in, and ultimately our goal is Fn, so we want, or Ft, so we can plug in for Fn. So to do that, I'm going to also move this over. So it'd be 180 minus Ft sine 15 is equal to Fn. And now we have this equation where I know what Fn is equal to, and I can plug in for Fn to find it. So on that note, I am going to So what I've done here is you add your 0.26 to both sides. I erase that bottom area to make room, so it would be 97.26 Ft, because this is what we're solving for, is equal to 180. So now the only thing left is solve for Ft, because that's what we want to know, what force she has to pull with. So you divide both sides by 97.26, divide 180 by 97.26, and you will get Ft equals 1.85 newtons. So anytime you're done with the problem, because that is our final answer, we want to know the force of her pull, or the tension in the rope, that is what it is. You always want to think, does that make sense? Well, yeah, because she's on ice. She's not going to have to pull very hard to get a sled going. And if she wants to go at constant speed, if you've ever known when you're pulling something across ice, you kind of just let your arm hang there, and you don't really pull hard, because if you just pull a little bit, it slides forward, hits you in the back of your legs, and it kind of hurts. So this is your answer. There will be one problem this hard and very similar on your test. So your notes are not done. I'm going to split it up into videos, but do go and do the spring notes. They'll be about 5 minutes. So now go to take some spring notes.